Okay, so we had, here were the answers to these two problems. Again, the first answer to the square root of 48 minus 4 radical 27 plus 5 radical 32 came out to be, here's my answer, negative 8 radical 3 plus 20 radical 2. And when we multiplied the 4 radical 6 times the 2 radical 15, we got, as a final answer, 24 radical 10. Okay, so what we're going to do now is we're going to finish up multiplication of radicals. And after we finish multiplication, of course, if we've done adding, subtracting, and multiplying, we're going to want to talk about dividing. And then we're going to talk a little bit about solving equations with radicals. So that's what we're going to be doing today. So let me first make one comment. You're going to see that they're going to be, I'm going to sometimes tell you, well, this is a quicker way of doing it. Sometimes there are more than one ways of doing something, but if there's a shortcut, I'd like to give you the shortcut so that you don't get stuck and mired in doing a lot of hard work that's unnecessary. And one of the shortcuts that we talk about is what happens when you, let's say, multiply the square root of 27, let's say I did the square root of 26 times the square root of 26. In other words, we're multiplying a radical by itself. Now, according to the rule, we should, since these are both numbers inside the radicals, multiply the 26 times the 26. And I have my calculator here so I can do that. And that gives me 676. So we get the square root of 676. And since I have my calculator, I can do the square root on my calculator. And I go to my square root button and I put in the 676. And the square root of 676 comes out to be 26, lo and behold. And actually, I could have done this much quicker. The whole point of when you're multiplying the square root of something by itself, if you're multiplying the square root of x times the square root of x, you're going to get the square root of x squared, which is just x. Anytime I'm multiplying a square root by itself, my answer is the number inside the radical without the square root. The square root of 26 times the square root of 26, I know has to be 26. I didn't have to take out my calculator. I could have gotten that answer all at once. And I'm going to use this fact a lot. Anytime I'm going to end up multiplying the square root of a number by itself, even if it's something like this, the square root of x minus 5 times the square root of x minus 5. Anytime I'm multiplying a radical by itself, if these two are identical, then my answer is just what's inside the radical, the x minus 5. It's a shortcut. Yes, I could have done x minus 5 times x minus 5. It would have given me a trinomial. I would have then had to try and take the square root of that trinomial. It would have been a lot of work. It's not necessary because I'm multiplying a radical by itself. It just gives you what's inside the radical. Okay, so this is something we're going to keep in mind as we work with these radicals. So let's say I gave you something like this. Suppose I had 2 radical 3 times 5 radical 2 minus 3. Suppose I wanted to Suppose I wanted to multiply a monomial, 2 radical 3, by a binomial. This is a binomial because I have two expressions. They happen to be subtracted, separated by a minus sign, or if it's either a minus or a plus, that means we have two terms. And notice we can't even combine these because they're not like radicals. And basically, we know how to multiply by a monomial. We have to use a distributive property. In other words, I'm going to have to multiply 2 radical 3 times 5 radical 2, and then go back to multiply 2 radical 3 by negative 3 radical 3. And we know how to do this individually. We basically know when we're multiplying, we multiply the numbers that are outside the radical together, and we multiply the numbers that are inside the radical together. So here we're going to multiply the 2 times the 5, that'll give me 10, and the radical 3 times the radical 2, which will give me radical 6. That takes care of my first term. Then I go back and I take the 2 radicals 3 and multiply by the negative 3 radical 3. So 2 times negative 3, those are the outside numbers, give me negative 6. And the other, what I'm left with is a radical 3 times a radical 3. Now, I could say it's radical 9, but I know the square root of 9 is just plain 3. And that goes along with the fact that whenever you're multiplying a radical by itself, it removes the radical. So for the second term, I'm getting negative 6 times 3. There's no radical here, so I could multiply these together. So my final answer becomes 10 radical 6 minus 18. And I can't simplify this any further because the 6 can't be broken down any further. And I can't combine the 10 and the 18 because this doesn't have a radical 6 next to it. They're not like radicals. This would be my answer. Okay. Before I give you one to try, I'm going to do one other example. Suppose I gave you something like this. Five minus 3 radical 2 times 3 plus 6 radical 2. What if I give you 2 binomials to multiply? Well, these, we know how to multiply binomials. We have to use what's called FOIL. It's just like regular binomials with x's in them. We use FOIL. Or you can say we use the distributive property twice. We multiply everything by the 5, and then we go back and multiply everything by the negative 3 radical 2. But since they're binomials, we just call it FOIL. So let's do the FOIL. First, 5 times 3. Well, that gives me 15. O is outer. That's the 5 times the 6 radical 2. Now the 5 is not inside a radical, so I multiply it with the 6. That'll give me 30. And there's no radical here to multiply by, so I just bring the radical 2 over. That's my outer. Now I do my inner. Inner is the negative 3 radical 2 times the 3. So again, I multiply the outside numbers. Negative 3 times 3 is negative 9. And again, I just bring over the radical 2. Because really, it's like multiplying it by a 1. And finally, last, I have to multiply the negative 3 radical 2 times the positive 6 radical 2. So the negative 3 times the positive 6 gives me negative 18. And the radical 2 times the radical 2, that's my easy one. That one I'm going to do, just make it into a 2. Let's see. Let me read the chat. No problem. Brandon, I'll mark you here. So now all I have to do is try and combine the like terms. Well, first of all, this negative 18 times 2, that can certainly be simplified because the 2 is no longer in a radical. So 18 times 2 is 36. So this is a minus 36. I combine the 15 with a negative 36 because those are just plain numbers without radicals. That gives me negative 21. And the 30 radical 2 and the negative 9 radical 2 are like radicals because they both have radical 2. So I do 30 minus 9, which is 21. So this is plus 21 radical 2. Don't try to combine this negative 21 with this 21 because these are not like radicals. I can only combine these like radicals. I wouldn't have had to have a radical 2 next to that negative 21 in order for it to be like radicals. So this would be my final answer. Okay, I'm going to give you one to try right now. And while you're doing that, I'm going to be taking attendance. So let me erase this and give you one to try. Let's say I ask you to do 4 radical 5 minus 2 squared. What if I asked you to square the binomial 4 radical 5 minus 2? Now, I'm just going to give you a hint. When you're squaring a binomial, you really have to write it twice. You do 4 radical 5 minus 2 in your first parentheses and 4 radical 5 minus 2 in your second parentheses. When you're squaring something, don't square each thing separately. You have to multiply the whole expression, the whole binomial by itself. Okay, so I'm giving you time to do that while I take attendance, listen for your name. Maury Labre. Hi, good afternoon. Chelsea here. Ariana.
I'm here.
Hi, good afternoon. Adina.
I'm here.
Hi. I know I could count on you. Great, Adina. Lachey.
I'm here.
Hi. Kava, I'm pretty sure I saw you earlier.
Yeah, I'm here.
But always nice and early. Terrence. Terrence. Hi. Karide.
Here.
Hi, Karide, did you see that I opened up the midterm for you as well?
Yes.
Okay, great. Cynthia? Faith Diggs. Ethan. Hi. Isabella. Isabella. Serenity.
Here.
Hi. Reggie, I see you answered the question, so obviously you're here.
Hello.
Zamia. Zamia. Brandon, I know was here. Michaela.
Here.
Hi.
Hi.
Seraphine.
I'm here.
Hi. Marissa. Marissa. Renee.
Oh,
Here.
Hi. Sky.
Here.
Hi. You can chat. Everything is open. If I thought you were maybe missing something. Try looking on Blackboard to see that you've done all the work. Jaden Roberts.
I'm sorry, were you referring to me?
Yeah, I was to you, Sky. Did you, let me look. I may be making a mistake. Let me check. That first test on Blackboard. You hadn't taken.
Oh, okay. I know. Thank you.
I opened it up. I wouldn't hold, in the end, I wouldn't hold it against you, but I really would like to see you do it.
Okay.
Great. Jaden Roberts. Kennedy Shelton. Felicia Simon. Hi, Felicia. Hi. Natalia Small. Hi, good morning. Good afternoon. The why I keep saying good morning, certainly not morning anymore. Michael Todd. Michael here? Cassidy. Okay, Michael, I see you're here. Cassidy. Cassidy here? Megan. Kalia Watson. Lauren Wade.
Here.
Hi.
Hello.
And Kayla Zakaria. Kayla Zakari. Okay, I think we finished with the. And I see, let's see. I see Reggie already gave me an answer to the question. Let's see if we can do this together then. Just check. I'm missing some people. Does somebody not hear their name being called? Because I have some, I have more people attending than. Okay, Chelsea, I see you're here. And Kizzy, I see you're here. Okay. That's it. Okay. Okay. So if we're doing this problem, again, anytime you have a binomial squared, you write it twice and you use your FOIL and you multiply. The 4 radical 5 times the 4 radical 5 will give you 16 times 5. Remember, the radical 5 times the radical 5 just gives you plain 5, not in the radical. Of course, now I can multiply this 16 with a 5 and get 80. That's your first term. Then you go to outer. 4 radical 5 times -2 will give you -8 radical 5. Then we do inner. -2 times 4 radical 5 is again another -8 radical 5. And finally, the last is -2 times -2, which is +4. Okay, now we want to combine our like terms. So first we have this 80 that has no radical next to it. So we can combine it with this 4 that has no radical next to it. The 8 and the 4 give me 84. And then the radical 5s, we have a -8 and a -8. Usually when you're squaring something, the two inner terms end up being the same, which they are in this case. -8 and -8 is -16. And don't try to combine this 84 with the -16, because this -16 is connected to the radical 5. This is like having an 84 minus 16x. They are not like radicals. This would be your answer. I hope a bunch of people did get that answer. Let me see. Okay, are we okay with this? This is, Adina, this was the same problem. This and this are the same problem. I just rewrote this problem. Whenever you have a binomial squared, you have to write it out separately, each two separately. That okay with you? Okay, great, I'm glad. Okay, so now let's go on further with this. I want to try a problem that's very similar to this, but not exactly the same. What if I had given you in one parentheses the 4 radical 5 minus 2, just like we had before. But in my second parentheses, what I have is 4 radical 5 plus 2. In other words, we don't, the binomials look very similar, but they're not identical. One has a plus in it, and one of them has a minus in it. Otherwise, they're the same. They are what we call conjugate binomials. We've used that term before. Conjugate binomials are binomials that look identical except for the sign in the middle. One will have a plus, one will have a minus. So therefore, it's not like you're multiplying something by itself. You are multiplying something by its conjugate. Now I want to see you to see what happens when we multiply these two conjugates. The first thing I'm going to do is a FOIL, just like I did before. So first, 4 radical 5 times 4 radical 5 is 16 times 5, just like what we had before. Again, the radical 5 times the radical 5 is just plain 5. And the 16 times 5 is, again, 80. That's the same. Now, the outer is the 4 radical 5 times positive 2, which will give me plus 8 radical 5. And the inner will be negative 2 times 4 radical 5, which will give me negative 8 radical 5. And the last will give me negative 2 times positive 2, which is minus 4. And if I want to combine the like terms, I have this 80 and negative 4 that don't have any radicals with them. So those are like terms. 80 minus 4 is 76. And the radical, 8 radical 5 minus 8 radical 5, I'm actually cancel each other out because these are identical, but one is positive and one is negative. Positive 8 and negative 8 give me 0. 0 negative 5 is just 0. These just cancel out. So my final answer turns out to be 76. And this is something that's going to be very important for us to realize. Anytime you're going to multiply a binomial with radicals by its conjugates, you won't, and when you're multiplying conjugates, you don't really have to do the whole FOIL. You could just do first and last, just the 4 radical 5 times the 4 radical 5 to get the 80, and then negative 2 times the positive to get the negative 4. Because when you're multiplying conjugates, the middle terms will always cancel each other out. So why do the extra work when you know there's not going to help? It's just going to be canceled out. So that's number one. And because of that, my final answer won't have any radicals in it. Even though we multiplied 2 binomials with radicals, my final answer is what we call a rational number, a number without any radicals. And that's something we're going to keep in mind because every time I'm going to see polynomials that are conjugate to each other, I'm going to save myself time by not doing the outer and the inner. Okay, so let's say I gave you this question. Okay, I'm going to give you this to do. We're going to see how quickly you can do it. 3 minus radical 7 times 3 plus radical 7. See how quickly you can multiply these. Okay, I think we had enough time to do this because this really should go quickly. There are obviously conjugate binomials. And I see a couple of people already got the answer. Because they're identical binomials, except one has a plus and one has a minus. So I can just forget about the O and the I and just do first and last. 3 times 3 is 9. Outer and inner cancel out. Don't even bother with it. Last, negative square root of 7 times positive negative square root of 7 is just minus 7. Because the square root of 7 times the square root of 7 just removes the radical. So my answer becomes 9 minus 7, which is just 2. Again, the answer, and that's what both of you got, excellent, is a rational number, a regular number without any square roots. Okay, so I'm glad everybody did that. We're going to see that this is going to be something that's helpful in our next step, which is, now that we know how to multiply, let's talk about dividing radicals. And you have to understand that when you're dividing radicals, that really you're working with fractions, and the way they want the answers, if they say that simplify, there's a specific way that the answer should be written. And every textbook does the same thing here. So it's not like this textbook does it one way and another textbook does it another way. Let's say I had a fraction that looks like this inside a radical. Let's say I had the square root of 3/8. Now, first of all, when you have a fraction inside of a radical, the best way, I think, to handle it is to separate and put both the numerator and the denominator in their own separate radicals. The square root of 3/8 is the same as doing the square root of 3 divided by the square root of 8. And when the term is used simplify or even divide, the whole point is to make sure that in the end, you don't have any radicals in your denominator. What they want us to do is something called rationalize the denominator. Rationalize meaning making it into a rational number, making it into a number without any square root. So again, we're always going to concentrate on the denominator. What happens to the numerator, we don't worry so much. If we can simplify it, we will. But first, our concentration is always on the denominator. We have to rationalize the denominator. Now, I know the square root of 8 could be broken down. 8 is 4 times 2. So this becomes a 2. So I could write this as radical 3 over 2 radical 2. That's our first step. See if you can in some way simplify that denominator, the radical of the denominator. But you're not finished here. Even though you can't simplify the denominator anymore, we always, when it says simplify or rationalize the denominator, simplify the fraction or rationalize the denominator, what you're going to have to do is you're going to have to somehow get rid of the radical that's in the denominator. Again, we don't mind if there's a radical in the numerator, but we never want to leave our fraction with a radical in the denominator. And the easiest way to do that is to multiply by the radical. I know if I'll multiply square root of 2 by square root of 2, it'll just give me 2. So that's what I'll do. I'll multiply the denominator by the square root of 2, which means, of course, I have to multiply the numerator by the square root of 2 as well. That's the beauty about fractions, that as long as you multiply the top and the bottom by the same thing, you're not changing the value of your fraction. So again, I'm always concerned about that denominator, so let's look at the denominator first. Here I have the radical 2 times the radical 2. That will just give me 2. So now I'll have the 2 times the 2. This 2 is no longer in a radical, so I can multiply by this 2 on the outside, and my denominator turns out to be plain 4, no radical. Let's see what happens with the numerator. Well, with the numerator, I have to multiply the square root of 3 times the square root of 2. Now, these are both in radicals, so I can multiply them together, and my final answer becomes square root of 6. I can't go any further with this because the square root of 6 is inside a radical. The 4 is outside a radical. We make sure we need our denominator to be a rational number. And just like you can't multiply a number outside a radical with a number inside, you can't divide it. So your final answer turns out to be radical 6 over 4. Now, some people would say, well, how is that simpler than this? That's the definition. To simplify a fraction with a radical means to get rid of the radical in the denominator. It doesn't matter what happens in the numerator, you must not be left with a radical in the denominator. Okay, let me see if you can do a problem like this. Suppose I give you 5 over radical 15. See if you can simplify that by rationalizing its denominator. Okay, let's see if we get that answer. Okay, so remember, when I have a fraction with a radical in the denominator, I concentrate on that denominator first. And I first see, could I simplify this radical 15? And the answer is no. 15 is only 5 times 3, neither of those are a perfect square. But I still want to rationalize the denominator. I want to get rid of this radical 15. So I'm going to multiply this by radical 15 on the bottom, because I know radical 15 times radical 15 will just give me plain 15. But of course, whatever I do on the denominator, I have to do the exact same thing in the numerator, because if I multiply by radical 15 over radical 15, I'm just multiplying by 1, and multiplication by 1 doesn't change your value. So therefore, this comes out to be 5 radical 15 all over 15. And now I see I can reduce this because there's a 5 outside the radical, and this 15 is also not in a radical. These are numbers outside the radical. I can divide both of them by 5, so the 5 cancels out. 15 divided by 3, 5 is 3. So my final answer comes out to be radical 15 over 3. And that would be the proper answer because you don't have any radical in your denominator. Okay, excellent, Adina. Okay, so let's go a step further. What happens if the denominator of my fraction is a binomial? What happens if I have something that looks like this? Suppose I have 3 over radical 7 minus 2. And the 2 is not inside the radical. Now, just listen for a minute and don't take notes. Again, the problem is this radical in the denominator. Even if it says divide, what you're really aiming for is to rationalize the denominator. You're aiming to see that there's no radical in the denominator. And I know that the first thought that anybody has is to, well, let's multiply like we did before by radical 7. But look what happens when I multiply by radical 7. Obviously, I have to do radical 7 over radical 7. And concentrating on the denominator, I have radical 7 minus 2 times radical 7. And I know when I multiply a binomial by a monomial, I have to use a distributive property. So I have to multiply the radical 7 times the radical 7 and get just plain 7, because when you multiply a radical by itself, that's what happens. But I'd also have to multiply the negative 2 by the radical 7. My numerator would be 3 radical 7. And I can't cancel out these 7s because this is a binomial. Remember, when you cancel, you're going to cancel a monomial with a binomial. And you're left with a radical 7 in the denominator. It hasn't helped the situation. If anything, it's made it more complex. So multiplying, that's why I told you don't take notes on this. Multiplying by radical 7 is not the solution here. So now I'm going to give you a little trick to try. If you remember what we said when you have binomial radical expressions, if they are conjugates of each other, you don't have to do a whole FOIL. You could just do first and last because the outer and the inner are certainly going to cancel out, number 1. And number 2, your final answer won't have any radical in it. So if I want to figure out something that I can multiply radical 7 by minus 2 by, so I don't end up with a radical, I'll just pick the conjugate. Now the conjugate of radical 7 minus 2 is radical 7 plus 2. Now, of course, whatever I multiply my denominator by, I'm going to have to do the same thing with my numerator. I'm going to have to multiply the numerator by the square root of 7 plus 2 as well. Notice I multiply not by the same thing, but by the conjugate, which is almost identical except for the sign. This had a minus, I had to get a plus here. I always like to do the denominators first because I want to make sure that my denominator is a rational number. And since these are conjugates, I just have to do first and last. Radical 7 times radical 7 will just give me 7. You multiply radical by itself, it just gives you the number. Negative 2 times positive 2, those aren't a radical, so I actually have to multiply them. That gives me minus 4. So my denominator turns out to be 7 minus 4, which is just plain 3. Let's see what we get in the numerator. So in the numerator, what I want to do is, there are two ways of writing the answer. One way of writing the answer is just to leave it in what we call factored form. Just put a parentheses. It's 3 parentheses, radical 7 plus 2. And actually, that's a very good thing to do because now I see the top is factored. It has a factor of 3. The denominator is also a 3. I can now cancel out the 3's. I can only cancel out the 3's because it's factors. Remember, this is now a 1. So my final answer comes out to be radical 7 plus 2. And that's how we deal with a fraction that has radicals in it, and the denominator is more than one term. The denominator is 2 terms. You just multiply by the conjugate. Okay, here's one for you to try. Okay, here I'd like you to try this one. Suppose I have 7 over 9 minus radical 7. I'd like you to simplify this by rationalizing the denominator. Okay, let's see if that's correct. Looks good. We want to, again, it might say divide, it might say rationalize the denominator, but whenever we see a fraction that has a radical in the denominator, we want to get rid of that radical. So this is the binomial 9 minus radical 7. So we're going to multiply this by 9 plus radical 7. And of course, whatever I do to the denominator, I'm going to do the same thing to the numerator. So again, I start with my denominator. It's conjugates, I just have to multiply the first together and the second together. Outer and inner, I don't have to worry about because they're going to cancel out. 9 times 9 gives me 81. Radical 7 times radical 7 just gives me 7. So this becomes 81 minus 7, which when we combine gives us 74. So my denominator is going to be 74. My denominator. Now my numerator, I can write in two different ways. I could write it as 7 parentheses 9 plus radical 7. I could leave it in what we call the factored form. Notice I can't reduce the 7 and the 74. If this would have been like 77, I might have been able to reduce it, but like this, 7 doesn't go into 74. I can leave my answer this way, and this is a perfectly good answer. Sometimes they distribute the 7, and you do 7 times 9 is 63, plus 7 radical 7. Don't forget, when you're multiplying, you have to distribute over 74. Both of these are perfectly good answers. Let's say if you were doing this on Delta Math, you would probably be able to put in either one of those answers and they would be accepted. When it's a multiple choice test, of course, sometimes they might give you this form of the answer and sometimes this. They won't give you both because they're both equally good, so they can't give you both because you won't know which one to pick. But either one is considered perfectly 100% correct. And again, the whole point is that you don't have any radical in the denominator. The denominator has been rationalized. Okay, let's just go one step further and talk about, now that we know how to add, subtract, multiply, and divide. Remember, simplifying the fractions is really what we do. That's what we do when it says divide with these radicals. We're really rationalizing the denominator. So now let's talk about what happens if we have an equation that has a radical in it. How do we solve an equation with a radical? And I'm going to show you how to do some really simple ones. And then we'll do one that's a little bit more complicated. And on Tuesday, we'll finish this topic. When we finish this chapter, there's still one more thing in this chapter to do. Then I'm going to be giving you a test. Probably the next test will be on Delta Math. I like to alternate the Delta Math tests with the Blackboard tests. So I think the next one will be on Delta Math, and it'll be on chapters 5 and 6. We are now going to be next week completing chapter 6. Okay, so we're now talking about radical equations. Okay, here's a very simple radical equation. The square root of x is equal to 9. A radical equation has a radical in it, and the x is inside the radical. Now, like with any equation, we always like to undo what was done. Like if we have 2x equals 10, we divide by, the x is being multiplied by 2, so we want to divide by 2. Do the opposite operations. And the opposite operation of taking the square root is squaring, multiplying something by itself. Basically, what we want to do is get rid of this square root. So we're going to multiply each side by itself. Now I know when I multiply the square root of x times the square root of x, that just gives me x. And when I multiply 9 by itself, it gives me 81. Now that makes perfect sense because if I replace the x by 81, the square root of 81 is 9. So this is a very good method to solve a radical equation. You want to get the radical by itself, and then you want to square so that you can get rid of the radical. Let's try a another example. What if I had something like this, the square root of x plus 2? Well, let's do plus 5. So here's a little bit more complex because we now have something added to the radical. But the concept is going to be the same. The first step, though, is to get your radical by itself. If there's anything outside the radical, bring it to the other side. It's like what we did when we solved absolute value equations. And the first thing we had to do was get the absolute value by itself. And then we get x equals 3 minus 5, which is -2. And you know what? I stop right here. Why? Because it's not possible for the square root of a number to be a negative answer. I didn't see that initially, but whenever we take the square root of a number, we always take the positive square root. Remember, we said that radical sign always indicates the principal square root, the positive one. So therefore, I can't have the square root of x equaling -2. This has no solution. Remember, this is our, either it says no solution or you put that no solution symbol down. So this is something we have to be aware of. Well, I want to do one more example and then give you one to try. Suppose I gave you the square root of 2a plus 1 minus 5 equals 2. I'm going to work this one out with you, and then I'm going to give you one to try. It's a radical equation. We first want to get the radical by itself. So therefore, I'm going to get this 5, and I'm going to add 5 to both sides. And I will get the square root of 2a plus 1 equaling 7. Once I have the radical by itself, I look, this is a positive number. In any case, I will always check my answer. But I know that if I have the square root equaling a number, I want to get rid of the radical, the square root, and I'll do it by squaring both sides. Now, when I square the side that has the radical, the square root of 2a plus 1 times the square root of 2a plus 1 is just the 2a plus 1. Squaring a radical just removes that radical. The other side is a 7. It doesn't have any radical, which means when I multiply it, I have to actually multiply it by itself. 7 times 7. It only removes the radical if there's a radical there. Otherwise, I really have to do the multiplication. So my next step gives me 2a plus 1 equals 49. I then bring the 1 over to the other side. That gives me 2a equals 48. And I then divide both sides by 2. And that gives me that my a equals 24. How can I make sure that I did it right? By checking in my original equation. Remember, I told you that it's very important for you to check equations that have fractions to make sure you don't have a 0 in your denominator. It's very important for you to check an equation that has a radical. It is possible to get an extraneous root there as well. You have to be very careful. So let's check the 24. I'm gonna do 2 times 24 plus 1 minus 5 equals 2. So the 2 times 24 is 48 plus 1. This is the square root of 49. Minus 5 is giving me 2. And we know the square root of 49 is 7, and 7 minus 5 gives me 2. So this is a good answer. 48 is the correct answer. And I checked my answer and it works. Okay, let's do, I'm going to give you one to try. Okay, here's one for you to try. Suppose I gave you the square root of 6x plus 1 plus 7 equals 2. Okay, I'm giving you time to do that. Okay, let's do this together. Obviously, my first step is to get the 7 to the other side. So if I get the 7 to the other side, I'm going to get the square root of 6 plus 1 equals 2 minus 7, which is negative 5. And according to my rule, I should square both sides. Now, when I square this side, the side that has a radical, I get the 6x plus 1. When I square the negative 5 times negative 5 gives me positive 25. And I subtract 1 from both sides. This gives me 6x equals 24. And then I divide both sides by 6, and I get x equals 4. But I don't stop there. I go to check. I go to check, see if x equals 4 works. Let's see if it does. 6 times 4 plus 1 plus 7 equals 2. Well, 6 times 4 is 24 plus 1. This gives me the square root of 25. And I know what the square root of 25 is. It's 5. And I get 5 plus 7 equals 2. 5 plus 7 doesn't equal 2. 5 plus 7 equals 12. It's not correct. I checked, and this was an extraneous root. There is no solution to this because it didn't work in the end. I did all the right work, but it wasn't good. And actually, I could have seen it right here if I had noticed. I can't have the square root of something being a negative number. If it comes out to be a negative number, I could stop right there because the square root always has to be positive. So there was no solution to this problem. Okay, I have to go now. I'm going to have a good weekend, everybody. Look out for homework on Delta Math. And I will see you next Tuesday.